Till last class we have discussed about data handling, out of order, outstanding, interleaving, and then channel dependencies, write channel dependencies, and read channel dependencies. Now, aligned transactions. What is aligned transactions? Whenever you start the transaction or transfer, you need a start address. That address is divisible by some bytes of data you are transferring. Suppose 4 bytes of data, that means 32-bit data you are transferring means. So that address, start address is divisible by that data. Okay, data bytes. If it is divisible by, suppose start address is 100 and it is divisible by 2, then your data size is 2, then 2 power AW size, then your data bytes will be 4 data bytes you are transferring. That 4 is divisible by 100 and gives you remainder is 0, 0 means then you are in aligned transactions. Okay, simply we can say that aligned transaction means you need to start from the beginning of your data block. Okay, so where you are beginning, where you are starting your data block, that place only you need to start, then it is aligned. And if you are not starting from the beginning of your data block means, then middle of the data block you are starting your transaction means that is unaligned data transfer. Okay, so simply that is the aligned and aligned transaction. See, data bytes are defined by 2 power AX size. So AX size means AW size or AR size. Okay, write address size or read address size. Okay, so that size, it is start address we are having. Start address is 0x some 1000 we are having. Okay, this could be percentile by data bytes. Okay, so data bytes means your data bytes maybe depends upon the AW size. Okay, AX size. So the AX size is 3 bit, right? So size, burst size is 3 bit. So depends upon the 3 bit, 3 tick 000, that means 2 power 0. 2 power 0 means 1 data byte you are transferring. And then 3 tick 0 B 111 means 128. Okay. So 2 power 7, 128 data bytes are transferring. So these 128 bytes is divisible by your at start address. Then if you got the value remainder is 0 means it is aligned. Understood? So see example, start address is 100 is given and then data bytes are 4. Okay, so this should be divisible by 4 and your remainder should be 0. It is aligned data. And then your memory is also allocating like this. See, I'm transferring 4 byte lanes. Okay, each byte lane having 4 byte lanes, and then 4 byte lanes, and then how many beats are transferring here? 4 beats you are transferring means, so starting address is 1000. Here 1000 is my starting, 100 is my starting address. So byte 0 is placed on 100, and then next byte 1 is also 1001, so 101, 102, 103. Okay, in this way the address is incremented. So if it is aligned means it is the multiples of 4 you are getting. That means 100 is the start address, and then next beat you are transferring. Okay, 0x104. Okay, that is multiples of 4 because your size is 32 bit. 32 bit means 4 bytes are transferring. For one beat, how many bytes are transferring? 4 bytes are transferring. That means, so beat 0, you are having that beat 0. In this beat 0, data 1, 2, 3, 4. Okay, so this is my start address 100, and then 101, 102, 103. Okay, this in this way my address is allocated. Then next transaction starts from 104. Okay, 104. That means, so it is multiplied by 4. And then next transfer is happening again, 4 datas, 1, 2, 3, 4 datas are assigned here. Okay, so this is 5. Okay, so what, where you are addressing that? So it is starting from 4 and 5, 6, 7. Okay, 4 datas are stored here. And then again next one starting with 108. Okay, next transaction is started from 108. See, so 100, this is my data. So byte word 100, 104, 108, and then 100C. So in that way we are getting the data bytes. Okay, so this is 0xfc is the another address, this address, and then fd, fe, and ff. Okay, the final address you are reaching. Up to that final address we are reaching the FC. So the FC is the starting address, and then FD, FE, and FF. So 2 bits. So we can reach that all the FF values. So up to that all F's we need to write the data. Okay. So that is aligned transaction. Why we choose aligned transaction means the performance is improved, fastest response will be getting. See, based on that burst transactions, the alliance will be depends on, see, AX size is here 3 bit we need to consider 3 tick B 1010. 010 means 2. That means 2 power 2. That means 4 bytes are transferring. And you are taking that increment burst. Increment burst means start address is 100 he is giving, and then length we are giving. Length means 4 beats of transferring here. Okay, you need to transfer the 4 beats. So beat 0. In beat 0 you are transferring, see this is the beat 0 address. Starting from 100, this is beat 0, and this is beat 1, this is beat 2, and then beat 3 you need to transfer here. All the beats are transferred. In every beat you need to transfer 4 bytes of data. That is starting address is 100, and the next byte is 100 not 101, and the next byte 102, and the next byte 103, 104, and so on. So we need to assign the address. See, every address is multiples of 4. Okay, that is burst based aligned transactions. Okay, so every byte is incremented by 4 bytes, so all the subsequent address will be remain aligned. Okay, because it is multiples of 4, multiples of 8, multiples of 16, multiples of 32. So in that way only it is incrementing means your data is aligned. Okay, see real time example. See, we are sitting on 4 members. So first person, second person, third person, and fourth person, all data bytes are filled means that is aligned. If any one is vacated, then it is unaligned. That means unaligned transactions are also supports here, but it will take some time compared to that aligned transaction. Aligned transactions improves their performance. Here, the address performance is increased, and then because aligned transaction completes in a clean way. So there is no cycles are splitting here, and then no more extra cycles are required to complete your transaction. Okay, simplicity. So if you are having hard logic in your hardware, okay, no need to use some extra bytes to making that complete data transfer. Okay, that is simplicity. And efficiency of using bandwidth, that means no bandwidth is wasted here, so your efficiency will be increased. And reliability, that means your behavior of your verification or your data on all corner cases and any other issues you are facing, all should be avoided here, because all the data are filled, so no data is left. In that every data is completed, and no further transactions you need to complete that remaining transactions. Okay, so this address, how we are calculating that alignment relation, that means AX address is there, right? AX address is there, and then log 2 of data bytes, data bytes 1 minus down to 0. Okay, so in that way we are assigning. That means AR address is 1000. Okay, this is the 100 is the address. Okay, and then your data bytes are 4. Okay, 4 bytes means what is that? 2 power 2 we can write. So log of 2 power 2 means you are getting 2. Okay, 2 down to 0 minus 1. So data bytes, what is the value? 2 down to 1 minus, sorry, what we are saying, 2 minus 1, that means 1. 1 down to 0. 1 down to 0 means 2 bit, right? 1 down to 0 means 2 bit. That means 2 power 2. 4 combinations are getting. That means, so first address 100, you are placing with 0, and then next address 1. Okay, so that means 101, and then second address 2, 102, third address is 3, 103. Then 100, 00, 01, 10, 11. So in that way, we can assign the what it called aligned address. Okay, so how we are calculating AX address plus number beat number. Your beat number should be 0, then you need to place the 0 here into your number of data bytes. What is the number of data bytes? 4 data bytes you are transferring. Okay, 0 into 4, then 0. So what is your AX address? 100. Okay, 100 plus, are you understood? Your AX address is, okay, AX address is 100 plus, okay, beat number. Okay, what is the beat number? 0th beat you are transferring. Okay, so 100 into 100 plus, okay, 0 beat into data bytes. 4 data bytes are transferring. Okay, so then you are data transferring the 4 data bytes. Then what is the address here? 0 into uh, 0 into 4, that means 0. Okay, 0 plus 100 is the 100 is your next address. Okay, starting address. And then next 100 is the start address. Again, first bit you are taking first bit into 4, that means 100 plus 4, that means 104. That 104 is the next address. Understood how I am calculating? Okay, see, key takeaway means align transaction means you need to start the address or correct boundary. We need to place the address is correct boundary. That means start boundary, wherever the address you have given, that address is divisible by your data bytes means that is the natural boundary or start boundary. Okay, unaligned transaction. So unaligned means that is not start in the start address. Okay, in between the middle of the data block you are transferring the data. So that means, so first data may be unaligned, the remaining data may be aligned. Okay, whatever the address you are taking, suppose 1001 you are considering. Okay, 1001 is the address you are considering, or 101 is the address you are considering. That should be divisible by 4. Then you are getting the remainder is 1, because up to 100 it is divisible. 25 4s are 100, and the remainder is 1. So this is what unaligned data transfer. Okay, your bus size and bus data types, based on that we need to assign that data. Okay, so here also size is depends on that. So 4 data size is 2 bit, that means 2 power 4, 2 power 2, 4 bytes of data you are transferring, and 3 bit means 2 power 3, 8 bytes of data, and then 2 power 4 means 16 bytes of data. So up to that 128 bytes of data you are transferring here. Okay, so this is size versus alignment requirements. So means you are divisible by these numbers means you will get the aligned data. That is multiples of 4 means you are getting the aligned data. You are not getting the multiples of 4 or multiples of 8, multiples of 16. You are not getting means that is unaligned data. So here 101, 102, 103 is not multiples of 4. Then you are not getting the data is aligned transaction. That means unaligned transactions are pending here. Okay. So these unaligned data transactions are required too many memory accesses. Okay. So that means may require two memory accesses. That means split or byte making. So we need to split the data. See which are aligned here. This is your start address. Okay. So and then byte 0 is 101, and byte 2 is 102, byte 3 is 103, and then byte 3 is 104. So this is next address starting. That next address is multiples of 4, right? First address is starting with 101. Okay, and then next address is 104, and the next address is 108, next address is 10C. So these three are aligned, this is not aligned. Okay, so that's what first address is unaligned, then remaining addresses should be aligned. Okay, understood? So this write strobe will tells you that which byte lanes are valid and which byte lanes are not valid. Here we will tells you that by strobe. Here this is the by strobe. So byte 3 is 1, byte 2 is 1, and byte 1 is 1, and then byte 0 is 0. This is invalid. So then this is unaligned. If all byte lanes are 1 means this is aligned. Your right strobe signals is having all signals are 1 means that means you are not starting with the divisible by 4 address, okay, or not you are not starting your data with multiples of 4, that means unaligned, okay. So this is also unaligned burst behavior. See, 101 is the unaligned transaction. That means 105, 109, and 10D that all are aligned. So first data is not aligned and the remaining data will be aligned. Okay. See, what is the differences between the aligned and unaligned? So aligned means you are starting with the starting address and it is divisible by 4, and then you need to start the natural boundary, and then unaligned there is no boundary here. Okay, and here right strobe signal, all signals should be 1 here, and here some of the signals may be 1 and partially it is occupied the data. Okay, in the right strobe, so 4 bytes of data we are having. Okay, 0, 1, 1, 1. So this is not valid data. These are valid data. And then 1, 0, okay, 1, 0, 1, 0. So byte 1 and byte 3 are valid, and byte 0, byte 2 are invalid. Okay, so that is unaligned. Clear? So we need extra logic to required to complete our data, and then so performance should be some more costly because here aligned there is no split data is required, but unaligned we need some split data to access to complete our data, and also all bytes are full in byte strobe signal according to the aligned data. But unaligned, all bytes are not filled. Some partial data only we are filling. Okay. So simply we can say that unaligned transactions are data starts in the middle of the boundary. Okay. So that can affect that some write strobe and split transfers or more cycles are required. That's cost to your performance. Uh, to avoid that to need your high performance, avoid this unaligned transactions. Clear? And then memory attributes catchability and bufferability. So what is that? Why we are required this catchability and then bufferability? Suppose I need to copy my data, write data or read data is there. I need to maintain some copy. At that time, bufferability is needed. And then if sometimes I want to make my data should be cancelled or modified. Okay, some data is modified. At that time, I need to make one copy. So before that, before the modification, then catchability is needed. Okay, so based on that catchability, and then here how we are doing the transactions, and then so is that any interconnects are there, that interconnects are communicating with properly, and then so we are not changing your data behavior, so system behavior only we are changing that. Okay, so at that time we need some memory attributes, catchability and bufferability. Okay, see here right allocation. See how 4 attributes are there. In that, right allocation is there, read allocation is there, catchable memory is there, that means modifiable, and then bufferable. So modifiable means you're maintaining the data, whether data can be cached or modified, you need to maintain a copy. And then if we want to do some other operation, we need to store the data, so for that bufferable is needed. Okay, so we have 4 bytes of data: bufferable, catchable or memorable, modifiable, and read allocation and write allocation. These are the 4 attributes we are having. Okay, so catchable means we need to maintain a local copy of your laptop. Okay, you need to maintain a local copy in your laptop, you need to maintain a local copy. And readable, read allocate means when you are missing any read allocation, at that time the read allocation will be maintained. Read miss, okay, so download the line and keep it in your laptop. Okay, keep it as a side. And then write allocation, it is also maintaining the first copy, so local first copy. So that is the read allocation. And bufferable means if you want to store your data, then bufferable is needed. Understood how it is happening here? See, bufferable means you are sometimes some reordered and then delayed of your transactions, that may be bufferable. Suppose in your interconnect, this is the one inverter and then other inverter. If you want to delay some transactions in your transaction, you need to add the buffer here. It will delay the transactions. That means if it is one, means your write transaction will be some delay. If it is zero, means you are directly going. Okay, no use, no need to delay in between the two transactions. Okay, you are assigning directly. Okay, your write transaction will be going directly without any delay. So catchable means if you are modifying any data, if it is one, means you need to modify your data, so and then it can be stored. If it is not zero, if it is not one, means so your data may be completely bypassed. That means your data will be transferred without any delay. Okay, you don't want to do any other things. And then read allocation, read allocation means if you are missing any line, okay, so you need to allocate that. Okay, so while doing the read transaction, if you are missing any data lines or any buffer lines or any information you missed, means this read allocation will take care of that. Okay, it will fetch the data and then read, stored in cache memory. Similarly, write allocation also. If you are missing any or allocating any uh, catching of the information or missing some information, means we are allocating the write allocation. Okay. So these are the common attributes. Some we need to allocate the memory master. From the master to interconnect, we need to connect. At that time, we need any buffer data. Write buffer is there, and if you want to modify your data, some cache is there, and then memory control is connected. After that, memory will be storing the data. Okay, this is how it works at the system level. So when you are needing that, so common attributes to combine, so combination of practical presets like is that needed bufferable, catchable, and read allocation and write allocation. When you are accessing direct memory, there is no need of all these things because you are directly sending the data. Okay, some normal cache memory or doing that means CPU is operating some data. At that time, you need bufferable and catchable and readable, all these things. Okay, so while you are going some right combinations, okay, so that means you need to do some regions of operation, or this region I want to do some right operation and this region I want to get the data. So in different mixing combinations you are doing, means you need some buffer, that means delay is needed, and then so right allocation we needed. Okay, so that means it is one or remaining or zero or one. Okay, so read allocation should be obviously zero because while doing write operation read should be zero. But you need catchable or write allocation. We need some doubt in that if it is allocated or not allocated. And read allocation also same. Okay, read allocation during that catchability is needed. Some modifications you want to do that, then you can do that. Otherwise, remaining data as it is, you can send that. Okay, same thing. Some write transfers with different attributes with burst based transactions. Okay, based on that burst based, we need to assign that aligned data. There is no need of other data, so all should be allocated in the same order. Then no need. So all the signals will be directly communicated with memory. So then there is no need of allocating the catchability, bufferability, write assigning, and read allocation. All these things are not no need. Okay. So fixed burst, we are having some different incremented burst and fixed burst. Fixed burst means same address we are maintaining that, and all the data are stored in your buffer. Okay, so fixed burst, that address is comfortable and then data will be directly going there. An increment burst, if you are maintaining at that aligned data, So it is multiple of 4, and you don't need any catchable or memorable and all these things. Okay. So this is access like protection and then instruction database and privileged access, all these things. So what is that instruction database and all these things we will discuss in this next slide. Okay. So privileged access and then secured access, normal access. Okay. So privileged access means there is a trusted data. Okay. So we have a trusted data, so that privileged access will be supporting. So see, protect signal is there. That protect signal will tells you that okay, you are having, your system is having, or your kernel is having privileged access. That can, privileged access means that can access any data. So critical sources, whatever the critical sources are having, all the data we are having access. See, privileged access, we have all the access, full access to all the system resources. Whatever the system resources we have full access. That means administrator or manager so will allocate that. Okay, you are the administrator, you have full access. Okay, what we need to access and what we need to what we don't want to access, all these things. Normal access means user applications. So user applications, you are giving some limited access. Okay, you are allowing some message reading, you are allowing that data reading, and you are allowing some restrictions we have. Okay, if you want to allow that, you can freely allow that. Or you have restricted means you don't want to allow that. That is the privileged access and normal access. Privileged means I told you that. So some master is there. This is the one master. This kernel want to drive the data through other slave. Okay, if it is privileged access means it will be accessed anywhere. Normal access means some of the access are denied here. Okay, some error response may become, you're maybe getting some decode error or slave error. That means your address is not matching or your slave is not responding. So that will be happening. Okay. So this is about the privileged access. So privileged access means there is a security in your access. Okay. Normal access means no security. So anyone can access. Okay. Anyone can uh, use your data. Okay. So that is the privileged access and normal access. Stability is there. In the protected OS is there, and then in that some any accidental or malicious access is happening, there is a security is there. Suppose your laptop is doing some installing some apps. Okay, your antivirus will detect you. Is there any faulty or some what it called malicious access is there? That means some threatening is there. Means it will stop that, or it is good means it will not stop that access. Okay, attack prevention. So why we are going for, so your data may be hacked by some other means, that will be preventing. Okay, see, we are doing the two-way steps verification. Why we are two-way steps verification means, so protection. Someone is not entering into your database. Okay, based on that database, you will get some OTP or some other information. Someone is trying to access your data means you will get some indication. That is the privileged access. Okay, clear? So
Yes, sir.
privileged access and then kernel memory. So privileged access means all the memories we are having the access. Okay, and then normal access means only some restrictions are there. So few of the data only we have an access. Other persons are not accessing. See, user application we are using. In this user application, you are doing some transaction. That means protect signal should be 0. Okay, so that 0 means normal access we are doing that. Check that. Is that having privileged access or security level? So what type of access level we are having? We need to check that. If it is accessing, if you are having privileged access, you can access freely entire slave memory. So memory resources you can access in everywhere. And you have normal access means you need to have some other, you need some restrictions to access in your slave memory. Entire slave memory you don't have access to use that entire memory. Somewhat memory only you need to access that. Okay. Normal means unprivileged access. And secure access means you have a protection. Okay, so in non-secured means there is no protection. So you are installing some apps means, so directly going to Play Store and installing some apps, there is a security. Some other apps you are installing means you may be some declined or it will show that, okay, your suppose you are accessing some UPI apps, while on turning on that Wi-Fi means it will show that your Wi-Fi is turned on. So turn off your Wi-Fi, then only I will give the access to enter into that memory, that means banking actions. So that what secured and non-secured accesses. Secured means your OS or maybe it's a trusted one. Okay, if data will be coming from the source is secured one, so that trusted source. Okay, and then normal means non-secured. That means non-trusted one. No, if in your own risk only you are doing the access. Otherwise, no one will give you the access only. Okay. See, master is requesting the data based on the interconnect. It will be give the, it will check that, okay, security level, memory region type, it will check that. So all access are there means freely accessible by the slave. Okay, whatever the slave is you are having, so you can allocate the memory and that memory can freely accessible. And here the access is denied means you don't have any permission to access that particular memory location because your slave is not responding or you are getting some decode error, address is mismatching. Okay, so security means allowed, all the access will be allowed. Non-secured means some of the access will be blocked. See what regions you need to get. So source region is secured means allowed, non-secured means blocked, and then non-secured region is also allowed, and this is also allowed. Normal access you can allow, and then peripheral regions. See all regions we have an access. You have secured region means, okay, you are operating in secured region, so trusted one, you have all the access. If it is non-secured or normal operation, you have only normal operation only you have access. So while entering into the some other places, some board is there restricted only, office staff only is entering, other persons don't allow here. Okay, so that's what. And then instruction or data, so what you are using, suppose instruction access means you are executing the data from the CPU, and then data means you are reading from the data from the CPU, so that means you are loading the data and then you are executing the data and then you are getting the data. So executing means instruction based, getting the data means data based. Okay, see, instruction access. Fetch the data, decode, execute, and write block. Here, load the data, so and restore it. You can access the data only. You don't have any executable things. Okay, you don't have any. You don't have any. What it called? Right to execute the data in that data mode. Okay, data mode means you need to get the data or you need to place the data. That's it only. Instruction means you have a chance to access the data as well as you need to execute the data based on the pipelining process. It will check that. Okay. See why we need separate instruction or data means security is there and then performance optimization and memory protection will be there. Okay. So these are the different operations. See same thing. Memory operation and then slave is that secured instruction access. We have access to we have an access to use that some other restricted areas also, and you don't have instruction data, only data type you are using means you have denied the access. Okay, so restricted accesses are not allowed to use that. Okay, so write strobe I have already explained that. Write strobe means which byte lanes are having the valid data, that will tells you. Okay, so in this write strobe you are having different channels, write address channel, read address channel, write response channel, read response channel. All these things are we are having. Okay, So if you are doing that AXI write data channel, that means AW address is there. Okay. Right, so we are using that write address channel, AW address, AW valid, AW, and then write data channel. So W data, W strobe, and then W valid or W ready, all these things. So W strobe signal, this strobe signal, which byte lanes are having valid data here. So byte lane 0, byte lane 1, 2, 3, 4 bytes of data we are having. 4 bytes means 32-bit data here. Okay, in this 32-bit data, all ones means all the data are valid data. If anything is 0 means that is invalid data. See, so here fixed address base we are using. So the address is fixed, 1000 address is fixed, and the data is also 121211223344 So this data we are having. In this right strobe, all the bits are 1 means all the bytes data are valid here. Here, first one is 1 and then second one is 1. That means byte 1 and byte 0 are valid. Byte 2 and byte 0 are valid. Byte 1 and byte 3 are invalid. Okay, based on that which locations we are having the 0 data, so that data are invalid data. Okay, so right strobe signals will tells you that which data byte lanes are valid. So you need to take care of that. So which are aligned and which are unaligned, it will tells you that. Okay. So these are the byte lane selections we will discuss later. Okay. So this calculation will be there, and in tomorrow class we will discuss.